Let's talk about the power that is absorbed or delivered by inductors and capacitors. So firstly, looking at inductors, we know the important equation for an inductor is that the voltage on the inductor is L times di dt, and our definitions here follow a passive sign convention, so that's a voltage and a current that goes from positive to negative. So basically with the equation for the voltage, we can just substitute that one into power is current times voltage, and thereby calculate the power that is absorbed or supplied by the inductor. And it can change over time. It can absorb power and then it can supply that power back to the circuit. It's an energy storage element. We can do a similar thing for capacitors. So I can take a capacitor and again I can define a voltage and a current. So passive sign convention, positive to negative for the current flow. And our governing equation for a capacitor is that the current is C times dV dt. So if the voltage is changing, then there is a capacitor flowing. And again, we can just substitute it into P equals I times V in order to get the power. And same as before, we can have a capacitor that absorbs some power for a while and then supplies power back to the circuit. So it's an energy storage element. And basically power calculations are the same as the sort of things you've already been doing. It's just current times voltage, and the only new piece is calculating voltages and currents using these new equations here. Now another thing that is important to recognize is how much energy is actually stored in each of these elements. So power tells us about the rate at which energy is supplied or consumed, but energy itself, because we have a storage element, it's interesting to know how much energy is actually stored. And there are derivations in the textbook, you can go and have a look, but basically energy, we're going to use the letter W for energy in joules. So the energy in an inductor is 1/2 times the inductance times the current squared. So 1/2 Li squared for the energy in an inductor. And for a capacitor, the energy in a capacitor is 1/2 capacitance times voltage squared. So you can really see the symmetry or the duality between these two circuit elements. Basically, in an inductor, if you have current flowing, then there is energy that is stored, and it's stored in the magnetic field that's inside those coils. For a capacitor, if there is a voltage across the terminals of the capacitor, then there is energy stored. And the energy is stored in the electric field. And in both cases, we have this kind of standard sort of energy relationship. You see this sort of thing in many places in physics. 1/2 times constant times sort of variable squared. So 1/2 Li squared, 1/2 CV squared is the energy that is stored in these elements here. And so these are equations that you should know. So you should just be able to write down what is the energy in each of these circuit elements.